There are 3 different types of acids. Tell me one of the acids that you know the name of.
Sulfuric acid.
Good. So we've got sulfuric acid. What is the chemical formula for sulfuric acid?
H2SO4.
Now, when an acid is placed in aqueous solution, tell me what you know about aqueous solution.
The solvent is water.
Good. Then solvent is water. What happens is the hydrogen and the non-hydrogen species separate. Do you know what the word for that is?
Dissociate.
Fantastic. So hydrogen and non-hydrogen species dissociate. So I'll write them over here. When the hydrogen separates, it becomes an ion. Do you remember the charge of it?
H plus.
Good. And because there are 2 of them, we put a 2 in front. Before, and I'm just going to show you this is an aside, before we had H2, that showed 2 hydrogen atoms covalently bonded. So if I was to draw that for you, the electron shells overlapping, the electrons are shared, so both of those hydrogen atoms have a stable electron arrangement. But when they separate, let's say just one H plus, it's now back to just having its one electron. So it's lost an electron when it's split up from the other hydrogen atom. So it's, when it loses an electron, what charge does it get?
Positive charge.
Yeah. And then we've got another one though, because this one also lost its electron. So that's why we put the 2 in front, because we've got 2 hydrogen ions. You following that?
Mm-hmm.
Okay. And then, because the acid, the charges need to balance it out, so because we've got 2 positive charges from the hydrogen ions, we need to have 2 positive we have to have 2 negative charges from the sulfate ion. So what's the charge of the sulfate?
2 negative plus.
And then we can double check that, because we're up to 2 negatives, so we've got 2 positive, 2 negative. What's the overall charge?
0.
Good. Balances out. Should we talk about another acid? Okay, tell me another acid you know the name of.
Nitric acid.
Good. And what's the chemical formula of nitric acid?
HNO3.
Well done. HNO3. And if you put an acid in aqueous solution, what happens to the acid?
What produces this?
Yeah, what will it produce?
A salt plus hydrogen.
Oh, so you're talking about if a metal reacts with an acid, salt and plus hydrogen are produced. So you're correct with that. But when we put an acid in water, it splits up into hydrogen and the non-hydrogen species. What's the term for that?
Dissociation.
Good. So when acid is placed in which solution?
Aqueous solution.
Good. The hydrogen and non-hydrogen species separates. What's the term for that?
Dissociates.
Good. Dissociates. So again, we've got HNO3. What are the 2 parts that nitric acid will dissociate into when placed in aqueous solution?
Hydrogen and nitrateness.
Okay, so just hydrogen like that?
Hydrogen plus.
So it's now a hydrogen cation, and what What about this?
A nitrate anion.
NO3. What's the charge?
-1.
Just -1. So let's have a look. So a positive one and a negative 1 charge. What would you say about those charges?
They cancel each other out.
Good. Any other questions?
No.
Hydrochloric acid is the same. So what would hydrochloric acid dissociate into when placed in an aqueous solution?
H+ and chloride -1.
Well done. What sort of charge?
-1.
Just -1, yeah? What about when, so that's the first example. So now, I've got a question. What if, and take a seat, what if we had magnesium reacting with nitric acid? What would the products be?
Magnesium nitrate plus hydrogen.
Well done. Now, this is really easy for you to do because you've already mastered this, but it gets more tricky when trying to work out the chemical formula of the salt. This is an example of a salt. So when a metal and an acid react, a salt plus water is produced. What if it was the acid was hydrochloric acid? What would the name of the salt be?
Magnesium chloride.
Good, magnesium chloride. Or if the acid was sulfuric acid, what would the salt be?
Magnesium sulfate.
Good, magnesium sulfate. So, what is the chemical formula for magnesium? Chemical symbol?
Mg.
Good. Nitric acid?
HNO3.
Good. Now, we know about hydrogen. What is the chemical formula for hydrogen?
H2.
Good. This is where it gets tricky. So what I would recommend that you do, and I'm going to show you working out in green, so the thought process. You need to think, what does this split into? So what does it dissociate into when placed in aqueous solution? And what is the answer? Do you know what nitric acid would dissociate into if placed in aqueous solution? That's fine.
H+ and nitrate -1.
Yeah, that's what I was talking about. And magnesium, what group is it in? Yep, group 2. So if it became an ion, what charge would it have?
+2.
+2. Okay, now out of these three, what are we interested in to find out the chemical formula of magnesium nitrate? Yep. NO3. Anything else? Yep. So we're interested in these two. So let's write these underneath. So we've got Mg, because we always put the metal first, 2+, and there is NO3 negative. So the charge of this, 2 positive, the charge of this one, 1 negative. Do those charges balance out? No. What do we need to do to make sure these charges balance out? Yep. Good, 2 in front of the NO3. So, for every 1 magnesium, we'll need 2 nitrates to balance those charges out. Now, the difficulty is, this non-hydrogen species, nitrate, is formed of more than 1 element. So, how do we draw that chemical formula? Yep. We put it in brackets, fantastic. So, is there anything that doesn't go in brackets? Yep.
The 2 in front of NO3 negative.
That, I've just put that in front, just to show you that instead of it having a -1 charge now, it's got a -2 charge now.
Oh.
Yep. You don't put the Mg in brackets, fantastic, because we only need 1 of it. Then what should I do? Yep.
Brackets NO3, close brackets, self-bituminous.
Amazing. That's so fantastic that you got that. Should we do another one of those? Okay, so Let's go with an even trickier one. Let's go with aluminium. What acid do you want to go with? Sulfuric. I like it. Ambitious. And what salt is made?
Aluminium sulfate.
Well done. And what's the final product? The other product? Fantastic. You need to improve your projection because you're on camera. We're recording this. So, can you tell me the chemical chemical symbol for aluminium and the chemical formula for sulfuric acid?
Al and H2SO4.
Good. We can't do this one yet, but what is this one?
H2.
Good. I want you to talk me through what we need to do to work out the chemical formula of this. Let's start with you.
You need to find out what sulfuric acid dissociates into.
Amazing, really impressed. So, what does it dissociate into?
H2 plus, miss.
Not quite, yep.
2H plus, miss.
Good. That's because, remember before I said to you, it was H2 because there were two hydrogen atoms covalently bonded together sharing 2 electrons. So they had a stable electron arrangement. But when they split up, they each lost an electron, so had a positive charge. And because they're separated, we put the 2 in front, not subscripts at the end. And what about this one? Yep. SO4 negative. Those charges don't balance out though. Yep.
There's 2 negatives.
2 negative, and then the charge balance out. And then what's the next thing we need to do? Yep.
You need to basically underline what your
So aluminium sulfate. Yep.
You need to underline what's going to be your reaction.
So what's going to be involved here? Yep, tell me.
Aluminium.
I haven't got anything to underline with aluminium. We haven't talked about it yet. What can you tell me about aluminium? What kind of ion does it form? It's in group 3.
Positive ion.
What's its charge?
Plus 3.
Okay, so now we would underline what? Yep.
SO4 2 negativeness and aluminium 3 pluses.
Now we'd write these out below. So we always start with what? The metal or non-metal component?
The metal.
The metal. So Al3 positive and SO4 2 negative. Now I'll write the charges underneath. So 3 positive, 2 negative. They don't balance, do they? We need to find the lowest common multiple of 3 and 2. What is it? Yep. 6. So we've already got a charge of positive 3. How are we going to get it to 6?
Times by 2.
So we'll put 2 in front of aluminium for now. So we'd have 2 aluminium, and that would change the overall charge of the aluminium to what?
Al6 plus.
It wouldn't change at Al6 plus, but I see what you've done there. In fact, the overall charge would be 6 plus, but we've got 2 aluminium ions, each with a charge of positive 3. Okay? And then, how do we get the sulfide to have a charge of 6 negative? Yep. 3. And what's the overall charge of it now?
6 negativeness.
Good. Now, we didn't write 2Al3SO4, would we? What do we do instead? I'm going to tell you with this one because it's quite tricky. So we start with aluminium, and we would write Al2. That subscript shows us that we've got 2 aluminium. Open brackets, SO4, close brackets. What am I going to put after it? Yep. Fantastic. Get it? Any other questions? I think that's all we covered today, isn't it? Okay, amazing. I'm just going to pause this.